Welcome everyone. Through this video, I am going to discuss an important topic of mathematics, that is mathematical reasoning. It is included in West Bengal Joint Entrance Examination as well as JEE Main. This is a simple chapter. Generally, a question of 4 marks will come from this chapter, and it is very easy to score 4 marks from this chapter. You need least effort to score 4 marks problem. So, mathematical reasoning. So, some basic idea. So, mathematical reasoning. First one is statement. Statement. Suppose Calcutta, Kolkata is capital of India. It is false. It is false. Earth is round. Earth is round. It is true. Earth is round. It is true. Shut the door. Shut the door. This is order. So what is mathematical statement? A declarative or assertive sentence which is either true or false is called statement. So answer will be either true or false, not the both. So earth is round, it is true, so it is a statement. Kolkata is capital of India, it is false, so it is a statement. Now shut the door. This is order. This is order. So it is not assertive or declarative. So not sentence. Sorry, not statement. Statement. Similarly, interrogative sentence. What is your name? This is not a statement. So a declarative or assertive sentence which is either true or false is called statement. So if a statement is true, we write it as T. If a statement is false, we write it F. So they are called truth values. Truth values. The truthness and falsity of a statement are called truth values. They are denoted by A or T. A or T. They are truth values. So now, just like sentence. So you know simple sentence, the simple statement. These are simple statements. Now compound statement. Compound statement. compound statement. If four sides of a quadrilateral are equal, then it is a square. Then it is a square. So look, four sides of a quadrilateral. It is a square. Two simple statements. So they are added by them. Then they are called connectiveness. So connectiveness. So there are four connectiveness, or this is called disjunction. And denoted by this, and this is called conjunction. This just like intersection. If then, so this symbol or implies symbol, and if and only if both sides is true, it is denoted by this symbol or this symbol. So we are discussing only the preliminary results. So they are connectiveness or disjunction and if and only. Now truth table. Truth table. So truth table of, we need four tables. Truth table of P, implication symbol, P arrow Q. So P, Q, and it is P arrow Q. So true. This is, it is defined as, if both are true, then it is true, false, true, false. So what is definition? So P arrow Q is false. When P is true and Q is false. So it is, otherwise it is true. So we need the basic concept. Now number 2, if and only Q. If and only Q. So P, Q, if and only Q. It means P implies Q and Q implies P. So this is denoted by if and only if. So what will be the truth table? So T T T F F F T. This is also again F F F T. So what is definition? So P double P if and only if Q is true if both P and Q have same truth otherwise false. So you know plus into plus, plus minus into minus, plus and minus and minus, minus plus minus. So this type same truth value, then it is true. Then truth value of truth table of number 3. So P conjunction Q. So P Q, P conjunction Q. So look, true, true. This is true. True, false. This is false. False, true, false. Again false. False, false. This is false. So look, P disjunction P conjunction Q intersection Q is true when P and Q have same truth. P and Q have same truth. Look, this is just like series connection. Look, series connection. Both the switches are on, then current passes this. This is series connection. Off, on, then it is off. On, off, off. Both are off, switch off. So this is truth table of this. So P conjunction Q is true when both are true. Then number 4. P disjunction Q. So truth table of this. P Q. So true, true. True, true, false, false, true, false, true, false, true, false, false, false. Look, it is false for one cases only. F. Otherwise, look, F. So it is just like parallel connection. Look, any of one switch is on, then current passes. T, F also T, F. So we need the idea of truth table. So 1, 2, 3 and 4. বাবু ঠিক আছে এখানে হাত দিতে বুতান একবার আইতো এখানে হাত দিতে গেল বুতান এই বাবু এখানে সে একবার কি পড়ে গেল now truth tables of P arrow Q, P conditional Q. This one P double arrow Q. This is called biconditional. So it is look T T T. If they have same truth value, then it is true. Then truth table of P intersection Q and P intersection. This is called conjunction and this is disjunction. Now, negative of a statement. Negative of a statement. Negative. Negative of a statement. Statement is denoted by P. Suppose P, earth is round. Earth is round. Now its negation, it is denoted by this symbol, negation P. So only we have to use not, earth is not round. Negation of a statement P is denoted by negation P. Earth is round, what is negation? Earth is not round. Now, then quantifier, quantifier, Q-U-A-N, quantifiers. So we use this symbol for all, this symbol, for all, there exists, so these are called quantifier. For all, for every, you can write for every, for all. For all, for example, for all x belongs to n, x plus 4 equals to 7 is a quantifier statement. So you remember this for all and there exist. They are called quantifier. So I am discussing only the terms we need. Next, contrapositive. These three are most important. Contrapositive, positive, converse, and inverse. Inverse of a statement. Contrapositive, converse, and inverse of a statement. So, if a triangle is equilateral, then it is isosceles. This is compound statement. There are two statements. P, triangle is equilateral. Triangle is equilateral. And Q, triangle is isosceles. So it is written in this form, P conditional Q. If a triangle is equilateral, then it is isosceles. Now, look, what is the contrapositive of the statement? So, contrapositive of positive of P arrow Q is negation Q arrow negation. This is quantipositive of a statement. So look, P arrow Q quantipositive is negation Q arrow negation P. So if we write the quantipositive of the above statement, look, reverse the statement and take negation. So what is quantipositive of the above statement? So if a triangle is not isosceles, negation Q, if triangle is isosceles. So if a triangle is not isosceles, then this conditional statement, then it is not an equilateral triangle. So in J-man, in West Bengal triangle, so this simple write the quantipositive of the statement. So it is, if it is problem of J-man, then it is also 4 marks problem. So it will take only half minute. So quantipositive of a statement. So P arrow Q quantipositive is negation Q arrow negation. Then converse of conditional P arrow Q is Q arrow P. That is, look, it is reverse. So if a triangle is equilateral, then it is isosceles. So what is the converse? Look, Q arrow, if triangle is isosceles, then it is equilateral. So look, very simple. What you have to recall it. P arrow Q is Q arrow. If a triangle is equilateral, then it is isosceles. So what is converse? If a triangle is isosceles, then it is equilateral. Reverse of the statement without taking negation. Then the inverse. Inverse of P arrow Q is negation P arrow negation Q. So what is the inverse of this? If a triangle is equilateral, then it is isosceles. So what is inverse? So inverse of the above statement, if a triangle is not equilateral, rule, negation, conditional, so then it is not isosceles. not isosceles. So these are the three important terms: contrapositive of a statement, converse of a statement, and inverse of a statement. So now we consider one problem of J-men. Now we consider negation of compound statement. Now negation of P intersection Q equals to negation P union negation Q. So look, actually this is just like a set. This is De Morgan's law. De Morgan's law of set. Law of set. So if we compare it with the properties of set, then this is replaced by union is replaced by disjunction. This is disjunction is replaced by union. Conjunction, this is replaced by intersection. Complement, this is replaced by negation, this is replaced by complement. So look, we compare it with the properties of set. We know complement of complement equals to original set. Just like you, negation of negation equals to original statement. Now A union B complement. De Morgan's law, you know. We know A dash intersection B dash. So negation of this conjunction is replaced by this junction. And look, this is conditional. Negation of P conditional Q is equivalent to negation P intersection negation Q. And this one you have to remember 4 and 8. Negation of P biconditional Q. So P biconditional Q means what? Implies P conditional Q and Q conditional. So if you P conditional Q, so negation is this one, and N is replaced by or. So Q conditional, then negative is this one. So now negation of quantifier. Negation of quantifier. So we have already stated for all derivatives, they are all quantifier. So if we take negative of quantifier statement, then we have to change, replace the word all by some and for every by there exist. By there exist. So these properties 1, 2, 3, 4, 5 can be proved by using truth statement. So let us discuss the negation of compound statement. Negation of compound statement. So De Morgan's law, negation of P intersection Q, we have already discussed it. Now we are giving proof. Now look, problem number 4, negation of P biconditional Q. So this will be P, this will be P conjunction negation Q. This will be P conjunction negative. So some modification. So look, we can prove it using truth table. So look, what are the statement here? P, Q, negation Q. So P arrow Q. So P intersection negation and negation of this. Now try to recall the truth table of P arrow Q. So look, P arrow Q, T, 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 F, T, F, 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 T, F, F. So it is only false when P is true, second is false. So this is P arrow Q. And negation of P arrow Q is F, T, F, F. Now, P this conjunction P conjunction Q, P intersection Q. So look, when both are true, then it is true. So P and negation T, F, F, T, T, both are true. So this is true. F, F, this is F, F, T again F. This is P intersection, inside it is intersection. P conjunction Q. Now, if we see this column, so T, F, T, T, so T, F, T, T, and look, negation of this is F, T, F, F, and this is also F, T, F, F. So what we can conclude? This equals to negation of P arrow. So this is using truth table. So these are negation of compound statement. So 1 and 2, this is De Morgan's law. Very simply, you always you know it. Very simply to recall. Now property number 4, negation of P biconditional Q. So P conjunction negation Q, and this one P arrow Q and Q arrow Q. So this union this and negation of quantifier. Now some definitions. Now we consider some terms, some definitions. So tautology. A compound statement which is always true for all possible true values of its component is called tautology. A compound statement, that is compound final statement, all is true, then it is tautology. A compound statement which is always true for all possible true values of its component is called tautology. So final statement, that is compound statement, all true values will be T. Now contradiction or fallacy. So opposite to tautology, a compound statement which is always false for all possible values of its component is called fallacy. So F, 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 F. So all truth values are false. Then it is fallacy. And next, contingency. Look, contingency. It is neither tautology nor fallacy. Then it is called contingency. Then algebra of statement, just like set. So look, we know commutative law of set A union B equals to B union A. A intersection B equals to B intersection A. That is dual property. Union is replaced by this. So similarly, you always remember by comparing with the properties of set. So look, commutative. P disjunction Q disjunction P conjunction Q conjunction P. This is commutative laws. Idempotent laws. So A union A equals to A intersection A also A. So similarly, P disjunction P equals to P conjunction P equals to P. This is idempotent law. Now associative laws. Associative laws. For three statements, P conjunction Q conjunction R. So position is changed. P conjunction Q, then conjunction R. And it is for disjunction also, just like union and intersection. So we need this property. We always use this property, distributive laws. Distributive laws. So look, A union B intersection C equals to A intersection B. A union B intersection A union C. This is distributive law, and similarly A intersection B union C. Where A intersection B union is replaced by this. So what is distributive? So look, distributive law. P, A is replaced by P. This is union. Union is replaced by disjunction. Q, conjunction R. So P disjunction, then conjunction P disjunction R. So P disjunction Q. So look, P this intersection, then P union. This is also union. And the second one, so role of this change. So this is distributive law. Now complement laws. So complement law, A union A dash equals to universal set. So similarly P disjunction negation equals to union. Union is replaced by T. Tautology. This is union. Union is replaced by tautology. Then look, A intersection A dash equals to phi. So P intersection negation P equals to phi. Phi is replaced by this. This is also most important property for solving problem of reasoning. And then absorption law. P disjunction P conjunction Q equals to P. So you know, get a look, A union A intersection. So this set A and this set B. This is union. So which one is greater? A. So we get A. Similarly, this one in case of using dual is P intersection. P intersection, that is P conjunction. P disjunction Q. So which set is smaller? This one. This set. So this is absorption law. So to solve problem, we need distributive law of set. Distributive law. Number one. Number two. De Morgan's law. Number three. Complement laws. These three are most important. Then negation of negation. Negation of negation is original one. And finally, we have to remember negation of compound statement. Negation, how to find negation of compound statement. So in this class, we have discussed only the basic idea of mathematical result. Basic idea of mathematical result. From the next class, in part 2, we shall discuss the problem of mathematical result. Thank you.